Well, so let us start from where we stopped in our last video. That was like, do note that this determinant is not an explicit function of our time. So we have to go for chain rule. Right. Now see that the Laplace expansion of the determinant along jth column gives us what? That along jth column it gives us right. So this one like so clearly if you do del del phi ij of this whole thing, so that will lead you to where? That will lead you to correct. Now this whole thing again we can write it is like this, replacing this bracketed term by Cij we can write this is Cij t comma tau. So replacing the bracketed term by this one we can write yeah, correct. Now see that we can change this order. What I'm trying to say we can do it's like, well, just we need to make this one j, this one I. This is j is equal to 1 and this one is I is equal to 1. My handwriting is not good, but I hope if you have some common sense and since you have made your journey till sixth semester, while skipping a few intermediate semester, but still reasonable amount of common sense is expected from you. So you can understand what I am trying to write or what I should write here. So this double summation on the right side, see, this one can further be written like this one, like this party. Just a minute. Let us delete a few trash because trash are no way good. Let us take it here. What I am trying to write here, that this ddt is equal to what we can write, that from this line it is equal to trace of that C transpose T comma tau d dt phi T comma tau, right? So now what we know, that what this gentleman produce, if you do this ddt, he has a bad habit of giving you an extra byproduct of AT, correct? So with this byproduct, and you know that when we are talking about trace of a square matrix, and all the square matrix are in this kind of multiplication form, we can exchange their order. They are means exchanging their order doesn't make anything any alteration in their result. So just let me check whether it's recording. Yeah, thanks God it's recording. So what you will get here is that Ct t comma tau phi, sorry, just a minute, let me do what I can do best, doing some copy paste. Oh God. Right. Well, so this last stage, it shows that the fact that trace is like independent. Now we can use this identity, like what identity we can use, that from where we got this identity, like if you do this, then you will get that phi t comma tau, if you take, then what, like, so if we use this identity in that expansion of this one, then we will get d dt det of phi t comma tau is equal to that here in this expression of trace it will become right. So this proves the whole thing. Because what we want to prove when we started for doing such mumbo jumbo, our objective was we were about to prove that date of this, means the left hand side bracketed term is equal to exponential integration running from tau to t trace a integration, right? Actually and accidentally a few terms got deleted, so oh no, it's there, yeah, this was what we were trying to prove. Then from this the direct consequence of this is this one. So we are, instead of directly trying to reach to this stage, we were trying to prove this one, and then got our result like this. Unfortunately, last day when I was just recording that video, due to some technical glitch, it got discontinued. Otherwise we could have like continuous discussion, and I'm sorry for that like suddenly interrupted or means incomplete video, but it was almost 50 minutes, so I uploaded it. Now I hope this one makes sense, and if you have any questions, obviously you people are very reluctant of asking question, but you should have some question and you should ask me, right? Now we will discuss some important state variable changes later on, which will be termed as homeomorphism in some way. Homeomorphism and diffeomorphism, we will discuss that. So this for my own sake of representation, I have written a few lines here. Say a state model that is described by a state equation x dot is equal to at xt and xt naught is equal to x naught. Then we are having we are defining another state transformation by this. This one is where P is a invertible. The condition of P is that P is a matrix with continuous and differentiable entries, right? So all the entries of this matrix is continuous and differentiable. Well, now what we can do is that if we now write x dot t, x dot t is what? X dot t, like this statement is alternatively you can write it like xt is equal to pt zt. So now if you do x dot t, then you will get pt z dot t p dot t zt. Now in this context I would like to mention that for time invariant system where your a is independent of time, in that case you can always have a p that is also this is a very important observation. For LTI system, you will have a continuous value of P, and therefore what you will have for LTI, this LTI, in case of LTI, the second term will not be there. You will deal with this one. So anyway, we are now considering a generalized case. Later on, means if sometimes it's becoming zero in the due course, then we can drop it. There is no harm, but we must go for a generalized analysis. So we are doing that, and while doing so, we are getting this, and then again we are putting the terms like here x dot t. Now this side we are putting first atxt and then replacing xt by pt into zt, right? Now from this, if we just do a little bit of side transposition, that means how we are getting this. Let me write the intermediate state. We are keeping it in left side, and the other terms are like and other terms be like at, pt, zt minus plus p dot t zt, or what it would become if you do sign manipulation, this. Now if you pre-multiply both sides with p inverse t, because p is invertible for all the values of time, you will get this result. Do remember that in case of your time invariant system, we do not have this term present. For LTI, this much is sufficient, but as we are dealing with general case, we need to consider this, right? So this is something is that one. Now why this is very important, like if we can do it, then what is the advantage? Like I may wish to convert it in diagonal form. Like if a is diagonal, then we have observed that it is like all the means your state transition matrix will only contain diagonal terms, it would become very easy. So it's a kind of similarity transformation, although the transformation matrix is time varying, but we are trying to do that similarity transformation and realizing some kind of easy to handle, easy to deal with matrix, right? So now consider this property like here, that your uh, like pt is equal to this one. Pt is continuously differentiable n cross n matrix, and we define our new state transition matrix. This ft is our state transition matrix. So this ft is that like means for this ft, the state transition matrix phi ft comma tau is given in this way. So now means what I said, it was based on my intuition. Right now we need to prove it. What I said is that if we diagonalize our system matrix A, then E8 to the power T will become a diagonal. That's okay. But for this here, whatever shape this FT will take, whether this is going to play the role of our state transition matrix or not, and more importantly, that this means modified state transition matrix can be obtained in this way or vice versa, we have to check it, right? So let us start this proof here, that we can write xt is equal to p inverse t, that arbitrary, but here tau is arbitrary constant, right? So here we are getting, now clearly we can write that x tau, if you put here, then what you will get, correct? Now this x dot t, from this we can write that x dot t is equal to what, is equal to minus, here we would like to exploit one property of matrix differentiation. If you are not very comfortable, you can visit or you can watch visit that YouTube channel of MIT and watch lecture number 22 by Professor Gilbert Strang on linear algebra, or else you can ask me. I am there to help you. I can prove it, that the property that is very straightforward, and we are going to exploit that property here. Just let me write it. However, here we need a very simple thing that I would like to show you. That is what we need, a property of matrix, any matrix that is having entries that are continuous and differentiable with respect to t. The d dt of a inverse t is basically, we can write it like minus a inverse t a dot t, your a inverse t. So if you ask me to prove it, it is very easy to show. Like, provided this is invertible. Now if you do ddt of this will give you 0. So this will become what? A dot t, A inverse t, plus d dt A inverse t, uh, your at, right? So this is equal to 0. Now you will have at d of A inverse t dt is equal to minus A dot t A inverse t. Now if you pre-multiply both sides with A inverse t, you will get this one is equal to minus A inverse t. This 2A inverse t will give you I. So basically you will have nothing here. So this is the result what we are going to exploit here. So now we can apply this here to write that x dot t is equal to, first of all, xt is equal to p inverse t phi a t comma tau p tau, right? Now that gives us x dot t is equal to minus p inverse t p dot t p inverse t phi a t comma tau plus p inverse t a t phi a t comma tau, right? Obviously p tau must be here. So now this gives us pt p inverse t at p tau inverse pt inverse t at pt, right, minus p inverse t p dot t, here it is p inverse t phi a t comma tau p tau, correct? Now this with this one we can see that what is this gentleman. This one was our if t, right, and this one was our xt. Now see that what we can say here is that from this relationship it is valid for any t. So our proof is complete. Now we will discuss one example and then we will go for our next video. So let me write the example, like a state variable change that we can use to solution, what type of solution we guess in our previous discussion is that, let us take the example x dot t is equal to okay. One thing I would like to mention here, that although I wrote it like x, it is let me actually that to make it different from our normal x, what I should do here is that let it be like a new variable is required. Otherwise you people will get confused with that previous x. So let it be empty, then it will become well. Now I hope that will make you free from the confusion that actually the book from which I took those derivation, they use that symbol capital X and small x were used to represent the state vectors. However, I think it is better to represent all the vectors by capital X, because in book they are having bold, italic, different type of font style, but I do not have. So that is why I wrote it using X. But then I thought it would make you confused. So don't get confused that M is a kind of matrix. And it was my objective to establish that one. So just to show that, like this guy that which is playing the role of M is actually the state transition matrix for the new system, because for all the cases state transition matrix, whenever you do this for normal state transition matrix, even you should get what? We are trying to establish here that same property, right? Here A is replaced by F, because this is the now the new system. It is this one. Well, okay. So let me go to the example which I was trying to discuss, that like that one. So zt is equal to See, there is no harm if we consider that pt is phi t comma t naught, because like all the entries of phi t comma t naught is continuous differentiable, as well as this one is invertible. So what was the prerequisite for pt? It is being met. So don't get surprised, or like it's heaven fall is taking place here. It's not like that. No such heaven fall, no such like nothing has been violated here in these two codes. Now see that, let me number this equation as equation 1. Now see that if we just uh, like substitute this in equation 1, this definition of state variable change, then what it would give us? It would give us like obviously this will become the definition, and your this one will become at phi t comma t naught zt plus phi t comma t naught z dot t is equal to at because means if you are having difficulty, what you can do is that, okay, let me do the few intermediate state, otherwise you will get again confused. Because the biggest problem here is that you people do not try to do it by yourself. See what is there, xt is equal to, so x dot t is equal to what? Is equal to now this pt is what? Pt is equal to correct. So from this you can write this one like it will become that the p dot t, so it will give you the first term. Right. Now the second term will be what? There was a right hand side that was, or originally it was atxt plus btut. So now you expand this guy, so you will get at etzt plus btut. Now what you will get here, that together with zt naught is equal to x naught. So now you will have z dot right z dot t is equal to, now see the substitution we have taken, that yields cancellation of, yeah, obviously p has to be replaced by phi t comma t naught, because yeah, this is our definition of p. So we can drop these two terms, therefore it yields z dot t is equal to phi inverse t comma t naught bt ut, while zt naught is equal to x naught. Now you can integrate both sides, like to get your things done. Or you can write it like x naught is equal to clearly this is a convolution, and this like gives us the rearranging. This gives us what? This gives us you can just use this, that changing the order will just do, so it will become on this step. I don't think you will get this step by yourself. I wish you get it. What you can do is that you can pause this video a while and try to realize the step by yourself. This to this, how we can write this. Isn't it very obvious? See, zt is equal to what? Zt is equal to your so this side it was, let me delete it. Try to means be a bit more like mindful and observant while you are watching a video. This is not a very easygoing subject. It will be easygoing once you decide not to be means panic with this one. So what you can do here is that you pre-multiply both sides with phi inverse, means phi t comma t, so that will yield you Now this guy can be replaced in reverse order like phi t naught comma sigma, and then we can use further property of this transition matrix that will give you what is the result, what I wrote earlier. Oh God. आ गया भाई. ये हो क्या रहा है? Yeah, this one what I was looking for. Sometimes will finally. So this is our end outcome. So I hope you have enjoyed the beauty how selecting our means state transition make everything very simple. Now your yt will be what? Cxt plus dut, that with this state transition you can write that one. Sorry, this should be ct, this should be dt, because we are dealing with time varying system. So ct will be how much? You just put this guy here. Right. So ct will be the whole thing. Plus dt ut. Done. So that's all. I will share the worksheet. Please try to solve that. Otherwise, actually, I am also not sure that otherwise how not solving or not following this class will cost you, because later on we will discuss in our next video that as it's for state transition matrix, it is not possible for me to knock everyone. I request everyone to be more proactive and try to be more participants, try to increase your participation in discussion, and try to let us have more discussion in each and every week. Otherwise things will become kind of meaningless, right? So guys, I request you once again that please be a bit more proactive with this course, because it is not possible for me to discuss everything over a lecture video, and also it is not like good if I discuss everything. And I'll be sharing the worksheet try to solve. In case of physical conduction of end sem, you can expect problems from that worksheet, because I am committed to confine the discussion within 40 lecture hours. So 40 lecture hours, obviously within that I cannot solve the problems which I used to solve when you people were younger and were in your third and fourth semester. But this time the time is short, only 40 hours, so I expect that you try to solve it by yourself. And in case if you face any difficulty, please get back to me. I'm there to help you, always be there, and will be happy to help you. But it is very difficult that if you consider that sir is omniscient and sir can figure out what is going in my mind, so it's not possible. Okay, and try to avoid rescheduling of classes, because it's like that will make no good use of your time. Okay, take some pressure and try to do it.